Yeah, talking about springs. Okay, so there's a couple of things that I first want to say about springs. Really, right, they stretch, they compress, they can do either one. And whether you're stretching or compressing, it does not matter. And yep, that pink line shows that it's basically at zero. We have two main equations for springs. One is F equals kx. One is the potential energy of a spring. It's equal to 1/2 kx squared. So I'm going to quickly run through like just a little physics demonstration, we like to call it. Whoa, you see that? Look at the spring stretch. And so it went a little bit further. So I show you this measurement here. It's about 1.4 centimeters, which we need to always make sure we have these things in meters. Really what I'm trying to show here is the linear relationship between the force applied to the spring and how much it stretches or compresses. So we're going to add a couple of different masses. So I think that first one was 50 grams, which again, just like the meters and centimeters, we have to make sure that we convert it to kilograms. We can't have that. All right, so now I think I'm putting on 125 grams, and we're going to see how much that stretches. Draw the little pink line over. There we go. We get our measurement there. Same kind of thing. I guess this is mostly just to show. Yep, 125 grams. Oh my gosh, look at those glasses. That's a good look. I should stick with that. All right, so we take this one off. We look around. We say, where is Waldo? And then we keep on going. Have you found him yet? All right, so this is a lot more. This is 325 grams. All right, got to just slide it over a little bit here so it has plenty of room to stretch out. And then I will take my measurement. All right, what are we? We got that there. Oh yeah, it's a solid thumbs up. All right, so 325 grams. You can't even see it. And then we draw our pink line over, and we get our reading. Okay, so what we're going to do now is we're going to make ourselves a chart, and we're going to, oh my goodness, look at those. That's a good look. That's a good look. I think I should do this. And then we got, I don't know what, those ears? Anyway, so here we go. We got a chart. So right across the top, we can say this is a silly thing to do. If you don't put any mass on, there is no displacement, and you're kind of good to go. All right, so one of the things I have to take note of here is, one, we have to have a mass, okay, in kilograms. Okay, and I'm numbering my data points here. And then we put in our information. So it has to be in meters. I guess I already said that. Okay? So we put in this information. We converted them. If you have any questions, just make sure you ask. You can throw them in the comments below, like, share, and subscribe or whatever. Okay, so you can see I'm going back and forth there, right? Making sure that I don't write down whatever my numbers are in meters, all right? So, and again, has to be in kilograms because I'm going to be measuring things in newtons and newtons per meters. Things must be in kilograms and they must be in meters. The first equation I'm going to use is Fs is equal to Kx. All right, so putting those numbers in mass are important because all I know right now is the amount of mass I applied to those springs. So if I want to know the force that I'm exerting on those springs, I'm going to have to use a different equation to determine that. I'm going to have to use our equation for weight. So if we know how much mass it is and we know the acceleration due to gravity, we can determine the weight. The mass has to be measured in kilograms. Gravity has to be measured in meters per second squared. So we substitute those numbers in. So just here's an example here, and then I'll show you that. We'll input it down here, and we'll throw the rest in. Okay, I don't need units in those boxes, remember, because they are up above. Okay, but what about that's just the weight. So what about the force that's actually being applied? What about that force in the spring? Well, gravity is pulling down. The question is, well, what is the spring doing? Well, that mass was at rest, so that means a force down and the force up have to be equal to each other because the net force there, the sum of those forces, is equal to 0. You can see I'm just running through this real quickly there in pink. So it means the force of gravity on it is the same as the force in the spring. So we can think of those two things as equal. Now that we have the force on the spring, we can now determine the spring constant using that Fs in pink there, and way back over in that second column, the x value, which again is the elongation or the compression of the spring. Substituting in those values, okay, is going to allow me to solve for that spring constant. Now, since it's a spring constant, it should be the same for each one of these data points. The spring constant is the same for only each individual spring, meaning it's different for every different spring, but it should be uniform within one spring, provided it's an ideal spring. So we solve for this, right? Do your math, you divide out, and you get, what do you get? 0.34. Okay, so that's for that. Oh, it's 0.35, sorry. So then we can go ahead and we can fill the rest in here and see how we do. 0.35, what's the next one? That one is 0.34. And then this next one, what is it? I don't know, 0.36. Okay, so now let's take a look at the graph, right? Something we do a lot of, pretty fancy. Okay, so we're going to input these data points, and then we're going to draw in our line. Couple of things. One, we're going to notice it's a linear relationship, which is good because we care about the slope of this line, and the slope of this line represents the spring constant. Okay, because delta y over delta x is slope, delta f over delta x, looking at our equation, would be the spring constant. So the slope of this line means the spring constant, which means the slope of this line should be about 0.34 or 0.35, hopefully around like 0.35. Okay, so we put those values in. Once again, slope is a delta y over a delta x. Recognizing that allows us to substitute in and solve here. So let me just take a quick peek at the numbers I'm throwing in here. I'll pick a couple of data points. A lot of times these questions say like using the graph. And if it says using the graph, you cannot use data points and you cannot just pick a couple of things and get an equation, right? And use the equation from, say, your reference table. You have to actually find the slope. And so you have to do one of these delta y, delta x's. Actually, it looks like these numbers are going to work out nicely, which is pretty awesome because this wasn't planned at all. And so physics works, which is super important. All right, so hopefully, there it goes right there, 0.35, writing things down. Hopefully this helped you out with springs, just a brief overview, and that you super enjoyed it, or that you just moderately enjoyed it. Hopefully you have some level of enjoyment, even if that level of enjoyment was negative. Otherwise, have a good weekend. Just kidding. See you tomorrow.